At this point, you've had a chance to see the base capabilities that BizTalk offers. You've seen the publish-subscribe architecture. You've seen that BizTalk can encode and decode messages using pipeline components. You've seen that you can install maps and send and receive ports to transform messages as they pass through. And you've seen that BizTalk can communicate over a wide array of network and application protocols by using adapters. And so it's not unreasonable to say that you can develop some very effective integration solutions using these features alone. So far, we've been working with applications that only deal with simple one-way or request-response message exchange patterns. Once a message has been received or delivered and any acknowledgments have been returned, then the conversation is over. BizTalk has retained its tracking data, but apart from that, it really has no recollection of those messages. As you get involved in more complex integration scenarios, it will become increasingly important to understand and to start taking advantage of BizTalk's ability to retain the data that it needs to start coordinating more sophisticated conversations between systems. And in the BizTalk lexicon, that ability is known as orchestration. So to begin this module, we'll start by talking about orchestrations at a conceptual level, just talking about what they are and what they can do for you. And then after that, we'll show you how to use the tools in Visual Studio to create an orchestration. And then finally, we'll deploy the orchestration, and when it's up and running, we'll send some messages through it, and then we'll go back and look at the tracking data that BizTalk has collected. We'll be able to see that data in the BizTalk Group Hub. I'm going to start this lesson by showing you a simple business process, and we'll look at it from a developer's perspective, and it will give us a chance to consider the implications of automating something like this. Once we've had a chance to think that through, we'll take a look at what BizTalk orchestrations are, and get a little bit of an understanding of how they work. And then we'll go back and look at that business process again and see how an orchestration can help us. And then we'll talk about the process of developing an orchestration, at least at a high level. And then we'll close this lesson by taking a look at the support that BizTalk offers for the Business Process Execution Language, better known as BEPL. Now this animation is going to step through a very simple purchasing process. And we're going to see along the way that it gives us a lot to think about if we're going to automate such a thing. So this purchasing process starts when a user submits a request for a purchase to our procurement system. Now we'll say for this scenario that this could be through a web application. It would be kind of nice though if the user could fill out the purchasing form offline if they didn't have access to the procurement system right at that moment. And then when they had connectivity, they could submit the purchase. But right now, we just have to live with whatever interface the procurement system provides us. So our user is ordering some materials for an upcoming project, but since this request has exceeded the limits of automatic approval, the procurement system needs to send an email to a manager to approve this purchase. Now there's no problem with that. But we need to consider that whenever we start involving humans in a process, we don't know how long it's going to take to get a response for this purchase order request. The manager might happen to see it at the exact moment that it arrives and instantly approve it, in which case it might be a matter of seconds. On the other hand, the manager might be out of the office at the moment and not have a backup, and so this could quite likely be hours, maybe even days. So as developers, we need to keep those considerations in mind. If we're going to automate a business process, we need to be able to retain all of the data that's required to complete that process. And we might have to hold on to that data for quite a while we wait for the process to complete. So then the procurement application also sends a notification back to the user to indicate that it's processing this request. So then eventually the manager logs in and approves the order. Imagine though if the manager could have approved the request by simply responding to the email from the procurement system. This could help things move through a lot faster. That could be really helpful when time is of the essence. Imagine also if the procurement system could handle more complex business logic and maybe evaluate the purchase request against a more complete set of business rules. Maybe this purchase wouldn't have required human intervention. Okay, pushing all that aside, now that the procurement system has approval, it is going to send a purchase order to our vendor. And then our vendor is going to respond, acknowledging that they received the order. So at this point, if you needed to know anything about this purchase order, you could ask the procurement app. It knows everything. Then our vendor sends a message to their warehouse to ship this order, and then follows up by sending an invoice to our finance system. Well, we've got kind of a disconnect here. Our finance application really doesn't know anything about this purchase order. So our purchasing data is divided between two systems. The procurement app knows some of it, and the finance app knows other parts. Imagine what happens when we start getting more systems involved in this process. So obviously that purchase order information is getting from the procurement system to the finance system somehow. But since it's not in this diagram, I think we can say it's more or less a workaround. Okay, moving on. So the finance app needs approval to submit payment for this invoice. So it sends a message to a manager for approval of the invoice. We have the same issues as the original approval of the purchase order, the delivery of the message, the wait for the response, any sort of connectivity issues that we might need to think about. The more options that we can offer for handling these messages, the happier everyone will be. And so then eventually our manager approves the invoice and sends that message back to the finance app. Our user might not even be able to determine the status of the order at this point. If they have access to both the procurement system and the finance system, they probably can get what they need. If they don't have access to the finance system, well, then they can only see what the procurement system has available. We also can't ask any single system how long it has taken to process this order so far. Okay, so setting all that aside, our finance system delivers a payment to the vendor. And obviously the process needs to continue to the point where the user actually receives the material that they ordered and this business process can be complete. Okay, so that brought up a few questions, but in this scenario, everything went as expected. What happens if we have a scenario such as this one, in which everything starts off just as it did before, but at this point we receive news that this project has been postponed. It won't start for another 6 months. And now the user wants to cancel the order. Well, the question is, who needs to clean this all up? Who's going to communicate this to everyone? Who knows how to submit the right message to the right location in the right format to cancel this order within each of these systems? Well, in this case, our procurement app is kind of stuck with it. And so it just needs to send out an email to everyone letting them know that this order is canceled and that they need to go in and clean this thing up. And canceling a purchase order is hardly an unrealistic scenario. Things could get a lot messier than this. So what are we going to do? Well, let's take a look at BizTalk orchestrations and see how they can help us with this scenario. Well, orchestrations, we've heard about those since day one. What exactly is an orchestration? At some level, an orchestration is a diagram of a business process. So the orchestration designer offers you a toolbox full of shapes that you can use to map out your business process. And as you add those shapes to your design surface, you can set properties on those and configure those to meet the needs of your particular application. And once you've completed all of that, and you have everything configured to meet the requirements of your app, you can hit the Build button in Visual Studio. Visual Studio will take all of the information that you provided in the Orchestration Designer and compile it into a .NET class. And then you can take that and deploy that to your BizTalk server environment. So with all of that in place, BizTalk can now accept messages on behalf of this orchestration. When it receives one, it can create an instance of your orchestration class, deliver a copy of the message to it, and let it process. When your orchestration has a message that it needs to publish back to the BizTalk message box, it can do so at any time. Now, your orchestration class can't do everything on its own. There is a runtime component that BizTalk provides that is known as the orchestration runtime. You'll also hear of it referred to as the xlang runtime. You'll see that show up in certain administration queries. Xlang is just the name of the programming language that underlies the Orchestration Designer. And when you hit the Build button in Visual Studio, that xlang syntax will actually be converted into C# code, some pretty complex C# code, but C# code nonetheless. And it's that C# code that is compiled into the .NET assembly. But the important point is that it's the orchestration runtime that knows when it should create a new instance of your orchestration class, when it should destroy an instance after the orchestration is completed. And it knows how to work with your orchestration class to manage this business process that you specified. Okay, so fine. My orchestration is a diagram. It compiles into code. I get to deploy it and run it. But really, what does happen at runtime? What makes orchestration special? Well, there's a little animation here that helps illustrate what orchestrations can do for you. So I mentioned a second ago that the orchestration engine knows when it should create an instance of your orchestration and when it should clean up and destroy it. Let's take a look at a runtime scenario. And so we have this BizTalk environment that's configured to host some orchestrations. And as messages arrive, the orchestration engine creates instances of our orchestration class. It allows those instances to process, and as each one completes, it cleans up after it and releases any resources that it was holding on to manage that process. So it's going to manage the memory that's available in the runtime environment. It's going to try to destroy objects as soon as possible so that memory can be reclaimed for use by other orchestration instances. And if the orchestration engine determines that one of the instances has been taking too long, and it's just holding on to resources that it's not using at the moment, it will serialize the instance of that orchestration and write all of that data to the message box, and then it will remove that object from memory and make that memory available to other components that need it. So that process is known as dehydration. The orchestration data still lives on. This instance of the business process is still alive. It can still continue, but it will just remain dehydrated until there's more work for it to do. In the meantime, the orchestration engine will continue to do its job, creating instances for messages as they arrive and destroying old orchestrations as they complete, while our dehydrated orchestration continues to wait for new data to arrive. When that purchase order approval, for example, finally does arrive, the orchestration engine will deserialize that instance of our orchestration into a new object, and that is known as rehydration. And then our orchestration instance is free to execute to completion, and once it's complete, the orchestration engine destroys the instance from memory, frees up that memory for other uses, and the cycle continues. So the orchestration helps maintain a stable runtime environment. It makes the best possible use of the resources available to it. And when the system shuts down, it manages that shutdown in an orderly way so that no data is lost. And in a catastrophic failure, if a server just closes down, if your orchestration is configured to run on more than one server in your BizTalk group, the orchestration engine is going to determine that it needs to create a new instance of your orchestration on another server and allow the orchestration to pick up where it left off. It really does offer some interesting capabilities. Okay, so now that we have some sense of what orchestrations are and how they work, let's see how they can help us in the business process we were looking at a little earlier. So here we have our user submitting a purchase request. Now you'll notice that I've redrawn this diagram so that that purchase request actually gets submitted to BizTalk, and then BizTalk turns around and submits a request to the procurement system. Well, how does that help us? Well, it does open up a couple of possibilities right away. First of all, BizTalk can support many different communication protocols. So it would be able to handle that if the user submitted that purchase order request as an info path form by email. It would also be possible to accept that request as a web service call. And that opens the possibility that another system that's monitoring a production line, for example, could automatically submit a purchase request for materials that it might need. Okay, so the procurement app once again needs approval for this order. Instead of sending the request for approval directly to the manager, the procurement system is going to send that to BizTalk, and then BizTalk will forward that on. Well, what's the benefit of that? Well, we once again have the possibility of using different delivery mechanisms. In this case, it probably does make sense to continue to use email. But it could make sense to send this request to a SharePoint site that serves as the manager's dashboard that they use to keep up on their day-to-day activity. At a minimum, if communication fails somewhere along the line, we can check with BizTalk and find exactly where that communication failure occurred. And then, of course, the procurement app is also going to send an acknowledgement back to the user, and this time it will be delivered through BizTalk. Now, when the manager approves the purchase order, that approval, of course, will pass through BizTalk, and BizTalk could support that scenario in which the manager simply replied to the email that they received in order to approve this purchase order. And to revisit that SharePoint scenario, BizTalk could download the approval from SharePoint, convert that into a format that the procurement app understands, and then transmit it. Okay, back to the procurement app. Once it receives the approval, it is going to send out a purchase order. Now that it's sending it to BizTalk, BizTalk is going to send a copy to the vendor, as expected, but it's also going to send a copy to the finance app. So the finance system is going to receive these purchase order messages in real time. And one other benefit of having BizTalk involved in this particular message exchange is that if either of these systems is unavailable, BizTalk can retry. So you saw how we can configure a send port to retry a certain number of times, and we could set the period at which the retries should occur. And then we could even set an alternate transport. So if our attempt to communicate over our preferred protocol failed, BizTalk can revert to a second option if we've configured it to do so. Worst case, if BizTalk fails all of those attempts, it will simply suspend the message, and when the destination system finally comes back online, we can resume the message and send it then. Okay, so the vendor then receives the purchase order and they send back an acknowledgement. This time they send the acknowledgement to BizTalk. And I wouldn't be too surprised to discover that a vendor finds it easier to communicate with BizTalk than it does to communicate with our procurement system. As always, BizTalk can provide more options in terms of connectivity. It can accept a web service call. It could accept a flat file over FTP. Now, of course, it's up to us as developers to implement those things, but BizTalk does make it feasible. So then once BizTalk receives the acknowledgement, it immediately turns around and notifies everybody who needs to know. So previously, only the procurement app received that acknowledgement. Now BizTalk delivers a copy of the acknowledgement to it, but it also turns around and sends an email to the manager who approved the purchase order. They're quite likely interested in that information. And it also sends a notification to the user who placed the order in the first place. And I expect that they too would be interested in that information. So then our vendor proceeds to fulfill the order and submit an invoice. And when they send the invoice to BizTalk, BizTalk turns around and sends a copy of the invoice to the financial system as well as the procurement system. Now the finance app doesn't need to be surprised about this invoice because it was notified of the purchase order automatically as soon as it was placed. And assuming that the procurement app has the ability to do so, it can update the status of this purchase order. So now the finance app needs approval for this payment. And we can see this message being routed all the way to the manager approving the invoice. Now, a possibility here is that we could have defined a set of business rules that might allow approvals of certain types of purchase orders. Perhaps we allow purchases of certain types of commodities within certain quantities within a certain price range. And those types of purchases can go through automatically. In that case, we wouldn't need to bother the manager with a request for approval. And who knows, maybe with a quick payment cycle, we can actually negotiate a lower price. But I'll assume that we need a manager to approve this invoice. So then the manager can submit the invoice approval to BizTalk by whatever means we have provided by using BizTalk's capabilities. And you'll notice that BizTalk turned around and sent a notification both to the finance system and the procurement system. So once again, it's keeping both of these systems up to date and in sync. Once the finance app has received the approval, it's going to turn around and submit a payment message to BizTalk. And then BizTalk delivers the payment to the vendor, and the process goes on to completion. Okay, well, what about the case if something goes wrong? How does BizTalk help us here? And specifically, what can an orchestration do for us? Well, as this example illustrates so far, our orchestration can sit in the middle of this conversation and coordinate all of these messages between these systems. One of the really cool capabilities of orchestrations is that it makes it easy to define compensating logic. So in other words, for every instruction that you provide for something that should happen if the process proceeds normally, you can provide a set of compensating instructions for what should be done if the business process needs to be rolled back. And it doesn't matter if this process has taken weeks to execute. If the business process needs to be rolled back, the orchestration will know everything it needs to know about this particular purchase order in order to work all the way backward through its sequence of instructions in order to undo each of the actions that it's taken. Of course, that requires plenty of work on our parts as developers, and we need to rely on business analysts to specify what needs to happen to undo each instruction. But nonetheless, the orchestration designer makes it easy to see where those instructions need to go, and it helps you organize those. We'll take a look at that in more detail in Module 10. The other thing to mention here is the reporting capability. And so since BizTalk is sitting in the middle of all this, coordinating all of this message traffic, it knows more than any other system about these purchase orders. So if we want to know how long it takes to process a purchase order on average, it only makes sense to ask BizTalk. If we want to know how much of some particular commodity we've ordered during the month of June, we could ask BizTalk. That all assumes, of course, that we're making use of the feature known as business activity monitoring. And I will talk more about that in an upcoming module. Well then, what does it take to develop an orchestration? Well, to start with, you'll need a set of schemas that define the formats of the messages that your orchestration will be processing. So you might receive these any number of ways. You might be able to reference a web service and let Visual Studio download and generate the schemas for you. Or somebody might give the schemas to you some other way. Or you might be working with flat files, in which case you will probably have to go into Visual Studio and use the flat file schema wizard to create your schemas. So whatever the case may be, once you have your schemas, you'll be able to start working on your orchestration. So you can start defining any type declarations that you might have. And then you can declare variables to hold your messages and any other variables that your orchestration might require. With those in place, it makes sense to start defining send and receive ports. Now these will be logical placeholders within your orchestration. They define entry and exit points, the points at which messages will enter your business process and when your business process will publish messages back to the BizTalk message box. And from there they can go to the outside world. After that, you will be ready to start adding shapes to the body of your orchestration. And this is where you start defining exactly what your business process is going to do. At some point, you will probably need to use shapes that allow you to assign new instances of messages, or to create one message out of another by executing a map. So once you have all of the shapes arranged and configured to meet the requirements of your business process, you'll need to build your orchestration. And at that point, Visual Studio will compile your orchestration into a class within an assembly. And it also gives you the option to deploy your assembly out to the BizTalk runtime environment. Once your orchestration's assembly is deployed out to the runtime environment, you have a little bit of configuration that you need to do. You need to configure the bindings of your orchestration. So what that means is that you have to tell the BizTalk runtime environment how to match the logical send and receive ports in the orchestration to the physical send and receive ports that you see in the BizTalk administration console. Once you have the logical ports mapped to the physical ports, then you can enlist the orchestration. And at that point, BizTalk can start accepting messages for your orchestration to process. But in order for your orchestration to actually process any messages, you need to start the orchestration as well. Once everything is up and running, then you can start testing your orchestration. And I highly recommend that you adopt a testing framework of some sort to accomplish that. And if you don't have anything available to you, you can always check out the BizUnit framework. You can find the BizUnit framework on codeplex.com. As you're working with BizTalk, you might occasionally encounter the acronym BEPL. That stands for the Business Process Execution Language. You'll find that BizTalk allows you to import and export BEPL documents. Microsoft and IBM and some other companies got together a while back with the goal of developing a universal language to describe business processes. In some sense, you could think of it as a level of abstraction above WSDL, the Web Service Description Language. WSDL describes what you need to know to call a particular web service. BEPL tries to describe what you would need to know to call a series of web services to complete a business process. So there are certain architectural tools that offer support for BEPL. You might not encounter any BEPL documents yourself, but if you ever encounter a BEPL document, you can import it into Visual Studio, and Visual Studio will generate a project that will help you get started implementing that business process. Now that we've talked about the basics of orchestrations, and we've gotten some of the concepts out of the way, and we have a sense of what they can do to help us automate our business processes, let's take this to the next level and actually start implementing an orchestration. So in this lesson, we'll take a look at what the Orchestration Designer has to offer and how it can help us develop orchestrations. We'll take a first look at some of the shapes that we can use within an orchestration. We'll take a look at how we can accept a message into an orchestration and use that to create a new message and then send that new message back out. We'll talk about these logical ports that we'll see in the Orchestration Designer, and we'll talk about how those relate to physical ports that we see out in the administration console. And then we'll talk about some of the options that are available to us when we're defining these logical ports within our orchestrations. And then I'll close out this lesson with a demonstration in which I show you how to create a very simple orchestration. All right, well, here we have it, the Orchestration Designer. So we're going to be using this tool pretty extensively over the next few modules. You got a glimpse of this in Module 1. So just a little preview of what it looked like. Well, now the time has arrived for us to look at it in more detail. So what do we have here? Well, you'll notice in the center, we have the area dedicated to our process. So this is where we add shapes and arrange the shapes in a manner that describes our business process. And so these diagrams can start growing pretty complex, but the orchestration designer helps us keep everything organized, and it provides the ability to pan and zoom so we can find our way around the orchestration. And then you'll notice that the process area is bounded on the left and the right by port surfaces. This is where you can define your logical send and receive ports. So those will define the entry and exit points that messages can pass in and out of your business process. There's no functional significance to the left surface versus the right surface. The designer is just giving you a couple of regions to place your ports in a way that makes your diagram the most readable. You might notice that there are a couple of icons at the top of the port surfaces, and if you click on those, you can actually collapse the port surfaces if you don't care about those details at any particular time. The next section of the orchestration designer to note is the toolbox. And the toolbox contains the collection of shapes that you can use. And you can add one of these to your orchestration by simply dragging and dropping a shape from the toolbox onto the design surface. Now each shape has a set of configuration properties, so once you add the shape to your orchestration, you'll need to visit the Properties window, where you can enter the values to configure that particular shape. Up in the right-hand corner, you can see the orchestration view, and this is where you would declare any of your variables. So you can see that we have some variables declared for our messages, and we have some instances of some ports. And you can create a new variable by simply right-clicking on one of the categories and then choosing Add New from the pop-up menu. As you saw in that screenshot of the orchestration designer, the designer offers quite a collection of shapes in the toolbox. So we'll start off by taking a look at a few of the shapes that we can use as we set about to write a simple orchestration. The first shape that our orchestration is going to need is a receive shape. And this receive shape is going to initialize a message variable. It's going to retrieve a message from a logical receive port, and it's going to assign that message to a variable in our orchestration. And then that message variable will be available to any subsequent shapes that have need of it. One additional option that we have with this receive shape is we can define a filter expression on it. So even though our orchestration might be set up to process sales order messages, we could actually set up a filter expression so that our orchestration will only receive certain types of sales order messages. And that very well could simplify our orchestration design if an orchestration only had to implement the rules to process a particular type of sales order. Okay, I'm going to take these a little bit out of order. The next shape that we need to talk about is the transform shape. The transform shape allows us to pass a message through a map to create a new message. So when we add this shape to our surface, we're going to need to configure it and pass it one variable representing the source message and one variable representing the destination message. And of course, we'll need to provide it the name of the map that it should execute for the transformation. Now that transform shape can't act on its own. Since we're initializing a new message variable, we need to declare that to the orchestration designer. And so that transform shape needs to be surrounded by a construct message shape. As long as we're inside of that construct message shape, the content of that message is still malleable. We can make alterations to it, and we can set message context properties on it even. But once we exit the construct message shape, all of that data has been persisted to the message box and we can no longer change it. And sometimes you'll encounter the need to copy a message from one variable to another. And so you can do that within a message assignment shape. And you can also copy context properties from one message to the other. And in the process, you can change the values of those message context properties if there's a need to do so. Okay, so the important point to remember here is the message assignment shape and the transform shape must always execute within a construct message shape. And a construct message shape always needs to declare which message variables it is initializing. And if we don't configure that correctly, we'll get a compiler error. And then the send shape instructs the orchestration runtime to take all of the message content, including the message context properties, and publish it to the message box through this logical send port. And from there, the message is free to be delivered to the outside world. So we'll be laying out the process and flow of our orchestration in the process area of the orchestration designer. And then as we need to declare variables and data types, we'll do that in the orchestration view. So we will generally need one or more variables representing the messages that our orchestration will be processing. And we simply right-click on the Messages folder in the upper pane of the orchestration view to create a new variable. We set the properties on it. Every message variable that we create, we will need to specify a message type. So there are a few options available to us. We could simply point to a schema, and that's what we'll be doing most commonly. And sometimes we'll need to choose our message types from a different category, particularly when we're working with generated code. If you look down below, you will see a list of multi-part message type definitions. And these were created by a code generator. Well, what is a multi-part message? Well, think of an email message. An email message could have a message body plus multiple attachments, each of those attachments being a separate part of the message. BizTalk would have no trouble handling that type of scenario. Quite honestly, it actually assumes that every message that it processes is going to have multiple parts. So even though the messages that we are passing through our orchestration have a single part, it is treating those messages no differently than a message that might have multiple parts. It uses the same data structures for all messages. So when we create a new variable and set the schema as the message type, beneath the surface, BizTalk is actually creating one of these multi-part message types for us. We just don't see it. This code generator, however, that created some message types that we can use to call a web service, chose to define those multi-part message types explicitly, even though they only contain a single part. You've heard me talking about logical receive ports and physical receive ports, and logical send ports and physical send ports. Well, what exactly does that mean, and how do they relate? Well, I have an animation here that shows you how logical ports are connected to physical ports. When we're creating these logical ports in the designer, we don't necessarily know what the physical ports are going to look like after deployment. So then when we do deploy our orchestration to the runtime environment, we get a scenario something like this animation depicts. When we deploy our orchestration, the BizTalk management database is aware of the orchestration as well as its logical ports. In order for our orchestration to actually receive any messages to process, it needs to have a subscription registered in the message box. What we need to do then to set up that subscription is we go into the administration console and we provide some configuration settings known as the bindings for our orchestration. In the bindings, map each of the logical ports to a corresponding physical port. Now, when a message comes in through a particular receive port and it gets published into the message box, one of the properties in its message context is the unique ID of the receive port. So, when we bind a logical receive port to a physical receive port, one of the conditions within the subscription is that the message context needs to indicate that this message arrived through the receive port that we chose in our binding. Now, once we've done that, our orchestration is ready to receive messages. Now, when a message arrives through the physical receive port, and the unique ID for the receive port is set in the message context, that message will be published to the message box. Our orchestration is now waiting for messages that arrive through that receive port. It also, of course, is only going to look for messages that correspond to the port type that we configured in the orchestration designer. And any message that matches those two conditions will be passed to the orchestration. Now on the outbound side, the scenario is reversed. When we have bound a logical send port to a physical send port, BizTalk will handle that case by adding a message context property to each message that is published out through the logical send port, and that message context property will be the unique ID of the physical send port. A physical send port always has a default subscription condition, and that is that it will accept any message that has its unique ID in the message context. So in this case, the message is published from the orchestration with that unique ID set, so that message is passed to the physical send port to fulfill the subscription, and then the send port transmits the message. So what exactly are we telling BizTalk when we set up these port types and logical ports? Well, there are a few different important pieces of information that BizTalk picks up from that. When we declare a port type, obviously we need to give it a name, but we're also going to declare a communication pattern. Notice I didn't say communication direction, just communication pattern. So we will create either a one-way port type or a two-way port type. We'll worry about the direction later. Another critical piece of information that we provide is the set of operations that our port type defines. And then each operation in turn is going to specify message types. So an operation on a one-way port type will specify one message type, and an operation on a request response port will specify a message type for the request, and it will specify a message type for the response. Now it might be helpful here to think of this in terms of a web service. At some point we will publish one of our orchestrations as a web service. And when we complete that publication, the operations that we have defined on our port type will show up as the operations in the WSDL for our web service that represents our orchestration. And by the way, speaking of publishing our orchestration as a web service, we need to set a modifier property on each of our port type definitions. And in so doing, we control the visibility of a port type. We might define some port types that pass data in our own internal schema format, and we intend that those will only be passing data in between our applications, and so we limit the visibility. On the other hand, we will have port types that will be passing messages that are for public consumption. And so depending on the types of messages that are being passed through a particular port type, we can decide how widely that port type should be made available. Now once we've specified all these settings on our port type, what about the logical port itself? Well, that's where we specify the communication direction. And so since we set the communication direction on the logical port itself, we could potentially reuse this same port type definition across many different orchestrations. Some who happen to be sending messages out through that type of port, and others who happen to be receiving messages through that type of port. Another setting that we need to configure when we create a logical port is the port binding. In the animation you saw in the previous slide, that scenario assumed that the logical ports were configured with the binding option known as specify later. In that case, we are specifying that we know that there will be a physical port out there that corresponds to our logical port, and after deployment, those pairs of ports will be bound together, and at runtime the subscriptions will be created and the messages will go through. Another option is specify now, and I actually avoid that option. In that case, when you create the logical port in your orchestration, you actually provide all of the physical details as well. So when your orchestration is deployed, it automatically creates a corresponding physical port in the BizTalk runtime environment, with all of those hard-coded settings applied. But the trouble is, even though you can go into the BizTalk administration console and override them, the next time you deploy that orchestration, your newly configured settings will be overwritten with the hard-coded settings. And then, of course, when you deploy that orchestration to a new environment, it will carry its hard-coded settings along with it. Of course, you can overwrite them there as well. From my perspective, it seems to just cause more trouble than it's worth. We're going to talk about direct binding and dynamic binding in Module 15, but I'll go over those quickly right now. When we configure direct binding on a port, we are taking complete responsibility for the subscription that will be created. And we do that by entering a filter expression on the receive shape. And on the send side, we need to make absolutely sure that we have all of the message context properties that are required to match the filter expression of some send port or of another orchestration. It can be a little tricky to get all of that right, but we'll revisit this in Module 15. It does open a lot of powerful options. Direct binding can be a very powerful tool. Dynamic binding applies only to logical send ports. If we have a message that needs to be sent out by email, we would actually need to determine the email address at runtime and then plug that email address into a property and send the message out through the dynamic port. And it's even possible to switch between protocols. One message could go out via email and the next message might go out via HTTP. It's very flexible, but it puts the responsibility on the orchestration to provide that information at runtime. But in some scenarios, that's exactly what you need. So taken together, the port type properties and the logical port properties give the orchestration runtime everything it needs to know to coordinate the message traffic going in and out of our orchestration. In this demonstration, I'll show you how to create a simple orchestration. I'll use the shapes that I described earlier, the receive shape, the send shape, the transform shape, and with that, the construct message shape. So this orchestration will accept a sales order message and it will map that to a restock message and then send that out. So we will need to declare a couple of message variables, one for the sales order, one for the restock message. I'll show you how to set up the transform shape that will map the sales order to the restock message. And then I'll show you how to set up the send shape to send out the restock message. And of course, we'll need to include a logical receive port and a logical send port. And once we have that ready, I'll show you how to compile the orchestration and then deploy it to the BizTalk runtime. And once the orchestration is out there, we have a few configuration steps to complete. So I'll show you how to do that. And then we'll start the orchestration and test it. All right, so here we are in Visual Studio. And it's time to add an orchestration to this solution. So I'll add the orchestration to the processes project. That orchestration will make use of the schemas and maps in the messaging project. So I'll add the orchestration by right-clicking, add, and new item. So just like any of the other artifacts that we've added, it's the same process. So this time I'll choose the BizTalk orchestration, and then this will be called our process order cache orchestration. And so the orchestration has the ODX extension, so it must be something like Orchestration Designer, and then maybe the X stands for Xlang. So here we are in the designer. The first thing I'd like to do in this orchestration is add a couple of new variables for our messages. So the first one will be a variable for the sales order message. And I'll add that by right-clicking on Messages, choose New Message, and then in the Properties window, I'll change the name to Message Sales Order. And then choose the message type. I'm going to put this properties window out here to make it a little easier to see. Okay, so to choose the new message type, I am going to choose the schema. And this schema is in the messaging assembly. And so there we have the memo.messaging assembly. And there is the sales order schema. So click OK to that. And now I need a message for the restock. I'm going to right-click, add a new message, and change its name to message restock. And then choose schemas. Okay, so we have two variables. Now we can start adding shapes to the orchestration, and I'll do that by going to the toolbox and dragging a receive shape onto the surface. Okay, now I need to set the properties on that receive shape, so I'll go to the properties window. This receive shape will simply be named sales order. And the message that it is going to initialize is the sales order message. And then we need to mark this receive shape as activating because we're instructing the orchestration runtime to launch a new instance of this orchestration when this receive shape accepts a message. We have an icon down here indicating that an operation needs to be configured, and we're going to come back to that later. Now we're ready for the transform shape. I'll drag a transform shape onto the surface. And you can see we got two shapes for the price of one here. If you remember earlier, I mentioned that a transform shape always needs to be inside of a construct message shape because the construct message shape is going to allow us to declare which message is being initialized inside these shapes. We might actually even initialize more than one because we could have any number of transform shapes in here. So we need to configure this construct message shape. So let's do that first. Let's give it a name. And then we need to select the restock message from the list. Okay, so we're indicating here that we are constructing a restock message in this shape, but you can see that it lets us choose more than one. Well, with that complete, we can focus on the transform shape now. So let's configure that. And I'll call this shape map to restock. Okay, now we need to configure the name of the map as well as the input and output message variables. So I'll choose this. And it gives us the choice of creating a new map. We want to use an existing map from the messaging project. So there that is. And we are going to use the sales order to restock map. And now you can see that this configuration window knows that this map expects a sales order message of some sort. And so it is automatically going to look through our list of message variables and pick out the variables that match that type. Well, we only have one, so that makes for a very short list. And then the same is true on the destination. It knows that it's expecting to produce a restock message, so it's going to filter the list in the same way. Also a very short list. And now we can click OK. So our transform shape is configured. Now it's time for the send shape. Rather than drag and drop from the toolbox, I'm going to use another method to insert this shape. And I am going to right-click in the position where I would like to insert the shape. And then I got a context menu, so I'll choose Insert Shape and Send. So that can be a little faster if you have many shapes to add. Let's set the properties on this send shape. And this will be the restock send shape. And this will be sending the restock message. And again, we have the operation that we need to populate, but we'll be coming to that in just a minute. Okay, now I am going to add the receive and send ports. And we can do that by going to the port surface and right-click, and then choose New Configured Port. And we get this port configuration wizard. And so it's going to ask us for a name. So this will be our sales order port. And now it's asking us for a port type. Well, if we look for the existing port types, we don't have any listed, so we need to create a new one. And it makes it very easy for us to do so. Almost too easy, actually. You can accidentally create port types that you don't need. So make sure you check your existing port types first. Okay, so that will be our sales order port type. It's going to be a one-way port, and we will restrict it internally to this project. Now notice that this is not asking us anything about the communication direction. So our port type, again, does not contain any information about a communication direction, because another orchestration could use this port type, and they might be sending messages in the opposite direction through it. Now when we click Next, notice that we are selecting port properties here, and this is where we indicate that we will be receiving messages. So we set the direction of communication on the port itself. Okay, we need to choose a port binding, so I will choose Specify Later. Click Next, and click Finish. We've got icons all over. So there's our new port. Here is our new port type. You can see that over here. And it doesn't yet know what type of message should be passed. Let's set the operation name to something that's more meaningful. I'll do that in the Properties window. And we'll name this the process order operation. Now, rather than leave the message name as just a generic request, let's give that a more meaningful name. So we'll call that the sales order XML message. Okay, so it's waiting for a message type, but we're going to populate that this way. Notice when I drag and connect, the icons disappear here as well as here. That's because we specified that this is going to accept the sales order message. And now when we establish that connection, the receive shape now knows its operation comes from this new sales order port. And the sales order port has now discovered that it is receiving a sales order message. All right, let's add a send port. And this one will be called the restock port. And we do not have an existing restock port type, so let's create a new one of those. And this will be one-way internal. Okay, this time we will be sending messages on this port. And again, I'll leave that as specify later. And now I can choose Finish. And there's our new send port. Let's set the operation name to something more meaningful. Okay, as well as the request name. And then I'd like to connect the send shape to the send port. And this orchestration is complete. Okay, we're ready to build and deploy. So we need to deploy the messaging project first because the processes project depends on it. So I'm going to right-click and deploy the messaging project. And you can see the progress. Okay, so that deployment was successful. And then let's do the same for the processes project. Okay, and that was successful as well. Well, I'm going to go out to the administration console and refresh the application list. And there is the new demos application. You can see the orchestration out here, and its status is unenlisted and unbound. So now we need to create the physical ports that this will bind with. So I can do that here. We'll call this the receive sales order. And then I'll add a receive location. And I'll call that the receive sales order file. Then we'll use the file adapter and configure that to receive an XML message from the all files demo code module 8 sales order in folder. Okay, and it will look for all XML messages. And now we need to do one more thing. Since this message will be passed to an orchestration, we need to use the XML receive pipeline. When the orchestration is enlisted, one of its subscription conditions will be the message type. And so the XML receive pipeline is the only one of these two that will add that to the context. So I'm going to choose XML receive and then click OK. And again, OK. Okay, now we need a send port. I'm going to call that the send restock. And that will send it to the file system. And I'll configure this to send that to the module 8. Out folder. And now we don't need to do anything special with this message on the outbound side. So I'll leave it at that. Okay, let's configure this. So we choose the host, and now we choose the receive port, and we choose the send port. And then click OK. And then right click and start. Okay, our receive location is enabled, our send port is started, and the orchestration is started. All right, let's right click, let's add a cache sales order message to the sales order in folder. And then let's check the output. There we have it. There's the restock message. All right, well, we have successfully developed a orchestration. Early on in our discussion of orchestrations, I mentioned that one of the benefits is that BizTalk would be collecting tracking data throughout the lifetime of the business process. Well, now that we actually have an orchestration deployed, let's see what BizTalk can provide. We can use the BizTalk Group Hub to view orchestration activity. And once we find a record of that activity, we can actually open that orchestration using the orchestration debugger and get some sense of what happened when our message passed through at runtime. In our case, our orchestration's pretty simple, but it can be very useful when your orchestrations become more complex and involve a lot of branching. You can use the orchestration debugger to see exactly which path the messages took through your orchestration. And then I'll close the lesson out with a demonstration so you can see what this looks like in practice. The Group Hub does a really nice job of reporting the status of your orchestrations, but the first time you see it, it might be a little hard to understand what it's trying to tell you. So let's start off by talking about the different states that it will report to let you know what's going on with your orchestration. So you can see in the left column, there is a list of states that are specific to service instances. Now, a service instance could be an orchestration, it could be a send pipeline, or it could be a receive pipeline. The Group Hub, of course, will let you know the type of each service instance. In the right-hand column, you will see a set of states that apply specifically to messages. So your orchestration might be dealing with a number of messages, and the Group Hub will report the state of each of the messages that's being processed by your orchestration as well. So let's walk through these lists so that you can understand what the Group Hub means when it reports each of these states. The first of the service instance states is known as ready to run. And in terms of an orchestration, that means the orchestration has work to do. It has all of the message information that it needs to do that work. It's just waiting for a chance to do so. Quite often when you see this in your development environment, it means that your host instance isn't running. So what you'll need to do is go into the administration console and make sure that that's started up. The next state is the scheduled state, and this really applies to send ports. You can configure a send port with a service window, and this is just saying that the send port has some work to do, but it's waiting for that service window to open up before it can actually transmit the message. You may also see a send port in the retrying state, and so this just means that its earlier attempts to transmit this particular message have failed, and so it's making another attempt to send the message. So you're familiar with our term dehydration from our earlier discussion, and if an orchestration has been serialized and dropped from memory, the Group Hub will report that as dehydrated. Now, if something has gone wrong somewhere in the process, your orchestration may be suspended. If it's not a critical error, and your orchestration could potentially recover, the orchestration runtime will simply suspend the message, but it will be marked as resumable. And assuming that whatever error condition had existed at the time is now resolved, that orchestration could be resumed and execute to completion. On the other hand, if the orchestration has encountered a critical error, then the orchestration runtime will suspend that instance and mark it as non-resumable. All of the state contained within the orchestration is saved off, it's not lost, but you won't be able to revive that orchestration and let it continue executing. You need to take the messages that it was working with and correct whatever conditions triggered the critical error, and then resubmit those messages to the orchestration so that it can start from the beginning. Another state that you will likely encounter is the active state. This means that the orchestration is in memory, it has work to do, it is processing, and everything is proceeding as intended. If you see that your orchestration is reported as in breakpoint, that means that someone has set a breakpoint within the orchestration debugger. And that orchestration is going to wait there until someone attaches to the debugger and then commands the debugger to continue execution. The last of the service instance states is completed with discarded messages. Now that sounds a little bit strange. What that means is that the orchestration has been designed to accept multiple messages, so it might sit in a loop and wait for 10 minutes for messages to arrive, and then when that 10 minutes has expired, it continues on. Well, this is saying that a message had just arrived before the orchestration's loop had expired, And so the BizTalk message engine had delivered a message to this orchestration, but the orchestration had already moved on, and so it ignored these messages that arrived too late. So the orchestration did complete successfully, but it had messages that it did not process. Now, your orchestration will likely be working with more than one message. And so the group hub will report a status for each of those messages as well. So let's step through these states that are specific to the messages. The first one is the consumed state. So this is what you would expect to see if an orchestration had accepted a message and was processing it. This next state, delivered not consumed, corresponds to the last state in the service instance list, the completed with discarded messages state. At the message level, then the status of that message will be delivered but not consumed. These next two states are identical to the suspended states in the orchestration. They mean something has gone wrong. This message is no longer in process. The next three states go by a few different names. You will see them listed as undelivered. You might also see them reported as queued, or you might, in the case of the last two, might see them reported simply as retrying or scheduled. So in the case of undelivered, the message has been queued. You may also see a message reported as retrying, and in this case, the send port is trying to send this message out, but it hasn't been successful yet. And then finally, you will see messages being reported as undelivered or queued, or simply just scheduled. And that means BizTalk is waiting for some particular service window to open up before it can send this message out. So as time goes on, you will probably encounter each of these states, and you'll grow familiar with what they mean and when they occur, and what you should do about each one. At some point, you will probably encounter a situation in which you need to know more than just the status of your orchestration. You might need to dig into the orchestration to see what's going on. And BizTalk addresses that need by providing an orchestration debugger. After an orchestration has processed, you can view its tracking data in the debugger. If an exception occurred, for example, you could see how far the orchestration progressed before the exception was thrown. You can also use the orchestration debugger for live debugging. What you'll need to do in that case is find an orchestration that has passed through your system, either successfully or even if it's terminated, and open that up in the debugger view and set a breakpoint on that orchestration class. Once you've done that, anytime a new instance of that orchestration is created, it will stop at the breakpoint. And then when you have an orchestration instance stopped at the breakpoint, you can open it in the debugger and attach to it and step through it at runtime. And at that point, you can set additional breakpoints on the instance of the orchestration. You'll also be able to see live data. You'll be able to see the actual message variables, including context properties and the body of the message. If you have any other variables defined in your orchestration, you'll be able to see the values of those. Finally, once you continue, all of those instance breakpoints go away, of course. The instance no longer exists. But just be aware that that breakpoint on the class that you initially set remains. And so until you remove that, all instances of that type of orchestration will be stopped at that same breakpoint. So just make sure you remove that breakpoint on the class, and then those orchestrations will be able to execute normally. So the feature set is a bit limited in comparison to Visual Studio. But nonetheless, it can be a pretty useful tool if you're trying to figure out what's going on with an orchestration at runtime. In this demonstration, I'll show you how to use the Group Hub to view tracking data. I'll send a message through our orchestration, open up the Group Hub, and I'll show you the information that BizTalk collected as the message was processed. I'll show you how to use the orchestration debugger to show you what happened after the fact. So we'll be viewing historical data in that case. And then I'll also show you how to use the orchestration debugger to connect to a live instance of an orchestration and step through it. Alright, here we are back in the demo environment. What I'd like to do is I'd like to send a message through. I'll drop a copy of the sales order message to the sales order in folder. Alright, that was picked up, and we see the output. So let's go see what kind of data BizTalk collected in the background. So I'm going to the New Query tab, and then selecting the Tracked Service Instances option, and then click Run Query. And now you can see all of the service instances, well, the last 50 service instances that executed. And you can see in this list that the messages that we've been sending through have gone through the XML receive pipeline, then through the process order cache orchestration, and then the pass-through transmit pipeline on the send side. And so you see that sequence repeated over and over here. This most recent message is represented by these 3 entries at the top. And so I'm going to right-click and then choose Message Flow, and then that will open a window. And this shows us some detail about the route that the message took through the BizTalk runtime environment. You can see the adapter information. You can see that this came in through the file adapter, and you can see the source folder. And now if we click on this link, this will take us to the tracking information that was collected for the orchestration. And so here we have the orchestration. We can see that the orchestration executed. We can see its start time and its end time. We can see that it completed with an exit code of 0, so everything processed successfully. And then we can see the send pipeline as well. And so this is showing us where the message was sent. And we can see up at the top the details of when exactly the message was sent and the status code. So this was sent successfully. All right, let's back up to the orchestration. And I'd like to show you the orchestration debugger. So we click on this link at the top, and then we see the orchestration debugger here. And so we're looking at historical data. And if you click on these entries one at a time, you can see the path of execution. So the green icon means that the shape started, and then the blue entries indicate that the shape completed processing. And so you can see this orchestration passed from start to end successfully. Now what I want to do is debug a live instance of this orchestration. So I'm going to right-click on this receive shape, and I'm going to set a breakpoint on the class. What that means is any instance of this process order cache orchestration is going to be stopped at this breakpoint. So I'm going to set this breakpoint now, and then we can close the window. And now we need to send a message through. So I'll send another sales order message through. I'll just paste the one that's already available. Okay, you see that it didn't show up in the output this time. So let's go check the admin console. And this time, I am going to check for in-progress service instances. Okay, you might notice here that we have one in breakpoint, and then there is a second message that is suspended not resumable. That suspended not resumable message is unrelated. That was sent through earlier. Okay, if we double click on that, it's going to show us that there is no error information. It's showing us the message that's being processed. And so let's open that in the orchestration debugger. So you can see that the initialization started and the sales order received executed. Now what we need to do is we need to attach. And at this point we are debugging a live instance of the process order cache orchestration. So you can see the variable list down in the lower left corner. And if you select one of the message variables, you can see the details about that message. You can see the details of each of these in the right-hand corner. And now we can set breakpoints on shapes down the line. There unfortunately isn't a step option. At this point we are setting breakpoints on the instance of this orchestration. So they'll go away when we detach from this orchestration. All right. Now we can continue, and this will take the execution to the construct message shape. Now you can see that we have the sales order message as it has been initialized. There is the content of the sales order message. Those are the properties that are associated with the content of the sales order message. And these are additional message context properties. These would have been set by the receive adapter and so forth. Now the restock message has not been initialized yet, so if we continue, now you can see that the transform shape has been completed, so the restock message now exists. And if we continue once more, the orchestration completes. Now if you run this query again, so the orchestration that is in the breakpoint is now gone. We still have the suspended message that is not resumable, so I'll terminate that. We're complete. Now we need to make sure that we go back in and remove the breakpoint on the class, and then close that. And there is the message. So if we paste one more message in to make sure, the message passes through successfully. So our breakpoint has been cleared. So there you have it. That's how you can track your messages, and then you can see the orchestration in the debugger, even to see historical information, and then you saw how to debug an orchestration live. In this lab, you'll be creating an orchestration like the one you saw me create in the demo, and then you'll deploy the orchestration out to the runtime environment and have a chance to test it out.